looks a little bit better. Yeah, okay, cool. Just go through each one, or you want me to check your answer? Are these your answers, or is that just the key? Okay. First case, we've got same base, multiplication is taking place. So what are we going to do with the exponents? You're always doing one level less than what the base is doing. Okay. Since the base, we have multiplication going on, then we're adding them, and that's how we get that answer. Okay. Now, in number 2, what we're doing is exponentiation. So what should we do with the exponents? What's one level less than exponentiation? Take a guess. If one level less than multiplication, or if one level less than multiplication is addition, what's going to be one level less than exponentiation? No, that would be one level less than division. In other words, if I was dividing the bases, I would subtract the exponents. When I am exponentiating, it's multiplication. Okay, so let's cross that out because that's not correct. So first of all, we're going to apply the -2 to everything inside the parentheses. So what is 3 to the -2? Because that's the first thing we're going to deal with. It's 1/9. In other words, 3 over here on the left, 3 to the -2 is the same as 1 over 3 squared. That's the way you handle negative exponents, always. It's just the reciprocal. So it's 1/9. Okay. And now what's x to the -3rd? All to the -2. Multiply the exponents. Multiply the exponents. You're not adding the exponents. You are multiplying them because we are doing exponentiation. We're not doing multiplication like we were in number 1. So x to the 6th. And how about the y? Yeah, now I can start off by writing it like that. Okay? But they say change all exponents to positive values. So how do I change that to a positive 8? Just put it on the other side of the fraction bar. That's all you do. And it works in all directions. So here's the final answer. Have all positive exponents. Everything's exactly where it should be. Now, let me just tell you something else. That about negative exponents is all you ever do with negative exponents is put it on the other side of the fraction bar. If I had this, okay, just put that 3 to the 4th, change it to a positive 4 and put it on the other side of the fraction bar. You can always do that. And that is the way to think of negative exponents. Okay? All right, let's look at number 3. That's exactly right. X to the 6th over 9y to the 8th. That's the same as 1/9. It's just I haven't written the 1 that's in front of the x to the 6th. Okay, so the way you want to do all of these is one step at a time. Okay, so for number 3, Let's do the numbers first, then we'll do the x's, then we'll do the y's. So what's the numbers? Simplify that. One-fifth. Same as 9 over 45 is 1/5. Now, what's the x value in the numerator? And we're going to do this one step at a time. We're not going to try to do all the x's at once. Just tell me what the x is going to be in the numerator. Okay. Okay. Now in the denominator, we still have that x and that y squared. Okay, so now we have to simplify that. Now, here's our fraction bar. Yeah, we still have the 1/5. What's our total x's? We are dividing now, so I'm gonna subtract the exponents. Here's a 1 right there. Subtract the exponents. What's x to the 8th divided by x to the 1? Subtract. You never do the same thing. It's just a good thing to remember so you don't make a mistake. You never, ever do the same thing to the exponents that you're doing to the base. So if I am dividing the base, I am not dividing the exponents. I'm subtracting. So it's x to the 7th. How about the y's? In the numerator. Now I don't need that 1 right there, but my final answer looks like this. X to the 7th, y squared, all over 5. Okay? Alright. Let's look at number 4. Now, the best way to do number 4 is just to apply that exponent to both parts. In other words, again, we're doing exponentiation. So what am I going to do with the exponents? Okay, so what's the numerator become? And what's the denominator become? And now get rid of negative exponents. How do I change this so I don't have any negative exponents? So tell me what it is. No, the y to the 8th already has a positive exponent. So it's exactly where it needs to be. Yeah, I need to move that, and that x to the 8 needs to go down there. In other words, to take an x to the minus 8th and move it to the other side of the fraction bar changes its exponent to positive. And I still need something in the numerator, so I got to put a 1 there. Can't just leave that numerator blank. If there's nothing else there, you got to put a 1 there. Okay? Okay, let's keep going. Let me just look at your math here. Looks like you did this one right. 5. You foiled it, which is what you need to do. About number 6. Looks like you did that one right also. In other words, on number 6, you do the numbers first. That's where you got the 4. And then you do those seconds. You just subtract the exponents, so it's 10 to the 4th. Okay. Let's see if I can scroll down a little bit to get to some of these other problems here. Yeah. Okay. Add, subtract, multiply, or divide. So, any questions on 7? Yes, you did. In other words, whenever you are adding, subtracting polynomials, you just add in other words, I'm going to add those together because they're both x cubes. I'm going to add that with this. There is no other x. Yes, there is. There's a plus 4x, so that becomes minus plus 3x, so you did that. And then you got the plus 3, so we got rid of that, we got rid of that, got rid of that, got rid of that. We still need that minus 9x squared, which you've got there. So yeah, you did that one perfect. All right, now 8 is a little bit harder because it's subtraction, it's not addition. And this subtraction sign has to be applied to everything in the parentheses that follow it. Okay, so let's see if you did that right. So how many x cubes do we have? Okay, so that's not right. We're going to do the x cubes first. How many do we have? No, we got an x cubed minus 4x cubed, right? In other words, that minus sign right there has to apply to that. What's 1x cubed minus 4x cubed? Yeah, so that's correct. Okay, now let's look at the x squared. So we've got plus 4x squared minus 1x squared. That is correct. Let's look at our x's. We got minus 5x. What else? Yeah, because this negative x turns into a positive x. So that is correct also. Might want to write your 4s a little different. It's really easy to confuse your 4s with your 9s. Look at how similar that 4 looks to that 9. So if you're going to write a 4, write a 4. There's no way that those two should look the same. Okay. And the negative 7 isn't correct. What should that be? Because that negative sign applies to that negative sign and turns it positive. So that should be a plus 7. Okay, let's look at number 9. When you have 3 binomials all multiplied together, the first thing to do is to multiply 2 of them together. Then you'll have a trinomial times a binomial. So let's just multiply those 2 together. What do you get? I can't really read your writing enough to tell whether you did it right or not. I'm just going to go ahead and redo it from scratch, just so I can show you exactly how to do this properly. So multiply x minus 4 times x plus 7 for starters. Now we're going to take that and multiply it by 5x minus 1. Now, notice that FOIL doesn't cover this. FOIL only works when you have a binomial times a binomial. When you end up with a trinomial times a binomial, you just do every term times every term. Start with the left, multiply that by that, and then multiply that by that. Go to the next term, multiply that by that, multiply that by that. Go to the last term, multiply that by that, and that by that. I call it ET. Every term by every term. So let's do that. Let me erase all my arrows. And the reason you want to do it exactly left to right and in proper order is so you don't forget certain ones. Sometimes you'll have a trinomial times a trinomial, and then it's really important that you follow a methodology. In fact, the very next question, we're going to have 4 quartic polynomial times a trinomial. So first of all, let's do this first one, the one I've got in red here. What's the first term going to be? Next term. Next term. Next term. Next term. It's 140. 140x. And finally the last term. That's the way you do it. And now, you're only always going to have one of those, and you're always only going to have one of those. But everything in the middle is going to get combined. So that's going to be 5x cubed. What's the total number of x squareds that we have? Takes care of that one and that one. How about our x's? And then that number. And that's your answer. So actually that is correct, except it's not complete. That's actually not correct. It needs parentheses. You need parentheses around that, right, like that. Now it's correct. In other words, now this matches that. Before it didn't, because it was missing the parentheses. And those parentheses are extremely vital there. Okay, let's do this term by term. Number 10. Where are you getting 9 from? No, you're adding. In other words, the base is what's being multiplied. I'm multiplying 3x times x, same base, so I'm going to add those exponents, not multiply them. Never going to do the same thing to the exponents that you're doing to the base. Next term. Keep going. What's that? You got it. In other words, what you've just done is multiply that by that, and then that by that, and then that by that. Now let's just keep going, and then there's lots of terms that are going to be on this one. Keep going. I'll just write down below. Okay. So you've taken care of the first two terms. Now that third term needs to be multiplied against everything. Okay. And again, we're only going to have one of those and one of those. The first and the last term, there's never any others in the middle that match those. Okay? So the rest of it is just combining. And let me show you a good way to do this. There's my first term. Now, I want my x to the fifths to be the next term, right? And I only see one of those right there. So minus 6x to the fifth. And as I do it, let's cross them off. Okay? And because I have so many terms there, it would really be easy to miss one. So how many x to the fourths do I have? Add them together. And then cross them out after you've done it so I don't redo that one. Now look at x to the thirds. Actually, I have three of them. I got one, a 9x to the third, a 5x to the third, and a minus 48x to the third. Negative 34. Negative 34x cubed. That gets rid of that one, and that one. Now, how many x squareds do we have total? Minus 74. Because I got a minus 18 and a minus 56. And what's left? Ones that aren't crossed off. So how many x's? Plus 19x plus that number, 15. Now I look at my list and I see everything's crossed off, so I haven't missed anything. I haven't done anything twice. So that's my final answer. And no matter how many, they could give you 6 terms times 6 terms. It would be exactly the same thing. I'm just going to do ET, every term times every term. Okay? Actually, that's pretty good practice on just math, on the arithmetic side of it, that last problem. Because that's all you're really doing is adding and subtracting, right? You're multiplying, adding, and subtracting. The whole problem is that. That's all it is. All right, number 11. First of all, do you know how to do long division with this kind of a problem? Okay, let's do it. There's 2 ways to do this. One is with long division and the other is with synthetic division. Probably you need to know how to do both, I would think. First of all, let's do long division. And with long division, you have to have every degree of x represented. And this so happens to have every degree of x in it. But say that 2x was not there, then I would have to put in a plus 0x. In other words, you need a marker. If a degree of a polynomial is not there, you need a marker, and that you put a 0 in front of that marker. But it would say 0x if there was no x there. Okay? Doing the long division is actually really easy. It's one step and repeat. First step, divide that into that. What is x divided into x cubed? In other words, what is x cubed divided by x? You can do the exponents when you're doing division. When you do multiplication, you add the exponents. So when you're doing division, what do you do with the exponents? Okay, well, subtract them. What do you get when you subtract the exponents? Okay. Now, the next step is to take that x squared and multiply it by both terms. So x squared times x, this is always going to be the same as the term above it. If you did your division right, it has to be that, okay? But now I got to multiply the x squared times the 2. And then, as in all long division, you subtract. What do you get when you subtract? No. Yes, no. I got minus 5 minus a 2. Right? In other words, I'm subtracting. So there's a subtraction sign between those two terms. Well, x cubed minus x cubed is 0. But what's minus 5x squared minus 2x squared? Turn it in. No, turn all subtraction. When you have trouble with a problem like that, just turn it into an addition problem. And then it becomes easy. Well, this is the subtraction sign, so that's the thing I'm going to change. And then I have to change the sign of what was being subtracted. Now I got minus 5 plus minus 2. What's that? Okay. So negative 7x squared. Bring down the next term just like you would in long division. And then start from the same place and do exactly the same thing. It's just repeat and multiply, or you do that first step and then you just repeat it the rest of the way. So what's the next step? What was my first step? No. My first step was dividing x into x cubed. This one right up here. That was my first step. So what's this first step going to be? Okay. What is that? Do the division. Divide x into negative 7x squared. Negative 7x squared divided by x. What is that? Subtract the exponents. Okay. Now, the way you can tell if you did it right or not is when you multiply that back, you get the same thing down there. In other words, minus 7x times x is minus 7x squared. It always has to be exactly the same. Now keep going. Now you have to multiply that minus 7x times the 2 also. What's that give you? Okay. Negative 14x. And now subtract. What do you get? Those always disappear, as they have to. That's the point. No. It's minus 2 minus a minus 14. Minus 2 minus a minus 14. Remember, you are subtracting. There's a big negative sign out there like that. No. No. Change. Here's your addition. Here's your subtraction. Change that to an addition. And by doing that, I got to change the sign of the term following it. So now it's minus 2 plus a plus 14. Okay. 12x. This is why arithmetic is so important. You really can't do anything higher in math without being able to do arithmetic. You've got to be able to add and subtract positive and negative numbers. You're just doing it all the time. Whenever you do any algebra, that's all you're doing. That problem before there, we must have done 12 different arithmetic operations. So you want to get really good at the arithmetic. You'll get through all of this just fine, except where I see your weaknesses in this little arithmetic problems. Okay? Now, we got 12x. The last step is to bring down the only thing we can bring down, repeat, and stir. It's the next step. Okay, what is that? Okay, that's a plus 12. And now multiply the 12 by both terms. What do you get? And now subtract. There's 0 remainder. So the answer to that is that, specifically, precisely that, no remainder. Now, have you been taught synthetic division? Let me do it synthetically over here. And what goes in the box? No, what goes in the box is the answer. If that is a factor, what is x going to be equal to? Minus 2. No, if I am dividing this long polynomial right there by x plus 2, and I want to do it synthetically, I got to put minus 2 in the box. I'm putting the 0 in the box. The 0 is what always goes in the box. It's not plus 2. If x plus 2 is a factor and I set it equal to 0, then I solve and x equals minus 2. So when I'm doing it synthetically, I'm always putting the 0 in the box. Okay? Now, what's the next step of synthetic? Okay, then what? And 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 then 0. That magic 0 means no remainder. And look what that is. That's our answer. That's x squared minus 7x plus 12. In other words, all we did was get rid of the variables. That's the difference between synthetic division and regular division. In regular division, I got all these x's I got to bring along for the ride at every step. Well, I don't do that in synthetic division. And because we were using a -2 instead of a +2, instead of doing subtraction, which is what we do with long division, we subtract at every step, and you can see how hard that is. In synthetic division, we add. That was a piece of cake. You didn't even come close to making mistakes. You did this thing synthetically in about 10 seconds. Whereas to do it by long division, it took you 2 minutes and you made mistakes. So synthetic division is the more accurate way to do these. Just got to make sure you do them properly. Okay? And the reason it's the better way is because I'm always adding. I didn't have any problem adding those to get -7. I didn't have any problem adding those to get +12. And yet when we did it by long division, you did have problems coming up with those numbers. So I would almost suggest that you do everything synthetically. So certainly number 12, let's do synthetically. What goes in the box? What goes across the top? Go ahead. You tell me the numbers, I'll write them in the right place. Oh, hold on. First you got to bring down the 1. And that's key, because that's part of our answer. In other words, that means it's x squared. That's 1x squared. We can't forget that. Okay, now 8. Now do it. Boy, look at how much easier you add than subtract. That's why you should turn all subtraction problems into addition problems. Then you won't have any problem with them. So what is my answer? What is that going to equal? Here's our answer right here. But you got to put the right x's back in there. What's that first one going to be? Is it going to be an x cubed, an x to the 4th, an x squared, or an x? What is it? No, we're dividing x cubed by x. Whenever you take a cubic and you divide it by a linear, you are reducing it down to a quadratic. Always, in other words, that comes down to a quadratic. This comes down to a quadratic. You can tell just by looking at the x cubed and the x. So this first term has to be x squared. And if that's x squared, the next thing's got to be x, and then that's the number. So there's your answer right there. In other words, the beauty of synthetic division is you get your answer when you're done. And that 0 tells you that that is a perfect factor. In other words, x minus 8 is a factor of that cubic. It's a perfect factor. It divides evenly this many times. Okay? Questions, or shall we go on? Okay. This looks like it might be, here, let me do this. Ooh. I hate the way Google does this, I really do. Where once you've opened a file, it takes it into your red files, and then it's hard to, Is this page 2 right there? Does it start on 13? Yeah, it must be. Okay. I can barely read this enough that we can do it. No, you don't need to. I can make it out. As long as you're looking at a reasonable copy of it, that's all that's necessary. Okay, so they want to sketch a graph of the polynomial, state all local maximums, local minimums, and end behavior. Also state all X-intercepts and Y-intercepts. Okay, this first one, what is it? Is that X squared? Really? This is weird stuff. This is all precalc stuff. Most definitely. This is almost honors precalc stuff. And it seems like I had these same questions at a previous session where, what are they doing here? All right, well, let's have a look at it. First of all, that's not easy to solve. Okay. We can use the rational factor theorem. If there is a rational factor, it can only be 2 or minus 2. Well, okay, that makes more sense. Yeah. Okay. Hold on a second. Let me just look at this one. Let's make sure you know how to do this even on a calculator. Okay. This one is going to look something like that. That's just the way cubics look. They have 2 humps in them. Okay. And what's a local maximum there? The way I've written it, that is a local maximum right there. So a local maximum would occur at x equal minus 2. Do you see why that is called a local maximum? Because there's points on the left and the right that are less than it is. That makes it a local maximum. Because all you need is 2 points. One to the left, one to the right. If they're both below this point, that's a local maximum. Do I have a local minimum? The way I've drawn it. That's it. X equal 2. So the way I've drawn it, I got a local maximum at x equal minus 2. I have a local minimum at x equal 2. Are either one of those absolute maximums? No. Here, way over here, that's bigger, right? That's higher up. So this is higher than this. So there's no absolute maximum. And is there an absolute minimum? Nope. That's lower than that one. So whenever you have something like that, I mean, in this case over here on 14, it's a quartic. A quartic has 2 humps. Like that. So a quartic might look like that. Okay? Now, there is a local maximum right there. There is a local minimum right there. What's this called? Well, it's a local maximum, but it's also the absolute maximum. In other words, for the entire picture, that's the highest point. So it's absolutely an absolute maximum. There's two kinds of extrema, which is what we're talking about here. There are absolute maximums and there are local maximums. There are absolute minimums and there are local minimums. Now, this one that I've drawn does not have an absolute minimum. This line here keeps going down all the way to infinity. So this is not an absolute minimum. This line goes all the way down to infinity, or negative infinity. But notice that that is an absolute maximum. There's no place on my curve that is higher than that. So that's the difference between absolute and relative. Now, let's talk about end behavior. First, we might as well go in order. I just want to make... It's not so much that you want to graph these as understand what they're talking about. Okay? So, if that is the correct graph of that number 13, what is the left-hand end behavior? There's left-hand end behavior and there's right-hand end behavior. And what they mean by that is as I go all the way to the left on the x-axis, what does the curve do? Negative infinity. So f of x goes to negative infinity as x goes to negative infinity. That's the left-hand end behavior, is as x goes to negative infinity. What is the right-hand end behavior? As x goes to this way, as x goes to positive infinity, what does the function do? Look at it. Make your eyes look up and down. What's the function doing? Okay. What's it going up to? Okay. Positive infinity. So that's the end behavior. Your end behavior is almost always an infinity. It's either a negative infinity or a positive infinity. Okay. Now, let's see. Also state the X-intercepts and the Y-intercepts. Well, there's an X. Hold on. Assuming I drew this right, and I don't care if I did or not, the whole point of this question is to make sure that given a curve, you can answer these questions. Okay? Because you're going to get the curve in your calculator. You're not going to graph it manually. So, there's an X-intercept. There's an X-intercept. There's an X-intercept. Where's a Y-intercept? Right there only. You with me? Okay. Now, let's go to the second chart. Now, that is a quartic. Quartics end up looking like this. Something like that. Okay? So, based on the way I drew it, tell me some local maximums and minimums. Starting from the left. Do we have a local minimum starting from the left? Always start from the left or the bottom. But when you're talking about maximums and minimums, they want to know where on the x-axis that occurs. So approximately, where does the first one occur? What's that number that's right above it? Yeah. So there's 1. local minimum. How about another local minimum? Nope. We're doing the minimums first. We're going to do all the minimums. There's two of them. There's one at -6. There's another one where? Okay. Now, how about maximums? Where's there a maximum? No. I'm looking for this point right there. What's the x value on that point? Okay. Well, you got to keep them straight. Okay. Now, there's a difference in the questions. If when they say they want to know where a local minimum is, they want to know the x coordinate of that local minimum. If they say, what is the minimum? Well, that local minimum is -5. This minimum is -4. So depending on whether what question you're being asked depends on how you answer it. In other words, usually they're asking for the x coordinate. Where does that minimum occur or maximum? They might also say, what is the maximum or what is the minimum? And those are different answers. In other words, it occurs at the x coordinate. What it is the y value. Okay? Now, is any of those an absolute minimum? Which one? Right. -5 is the absolute minimum value of y during that entire graph. What is this? Is that a relative or an absolute maximum? Correct. Local. Relative means same as local. In other words, there are values up here and values up here and values up here that are all higher than that, right? So there is no absolute maximum. The absolute maximum is infinity, but that's not a number. It's just growth without bound, so it's not called an absolute maximum when you have infinity. There is no absolute maximum on this graph. There is an absolute minimum right there. Okay, now let's talk about end behavior. What's the left-hand end behavior? No, what you're looking for is as x goes to negative infinity. So make your eyes go left, right. As we're going in that way, what does y do? To what? Positive infinity. That's what they mean. When they ask about end behavior, the answer is always either a positive infinity or a negative infinity. Okay? Now, what's the right-hand end behavior? As I'm going that way on the x-axis. Again, yes. Notice that this one, the end behavior was both positive infinity. Whereas over on this other one, we had something that looked like that. So this end behavior was negative infinity. That end behavior was positive infinity. And that is usually the case when you have cubics versus quartics. Quartics usually have their two ends going in the same direction. It's not always up. Sometimes a quartic might look like this. So the end behavior on this one down here would be negative infinity on the left, negative infinity on the right. Okay? And again, on your calculator, you can find these X-intercepts and Y-intercepts. What kind of calculator do you have, Brendan? Okay. You know how to do all that on the calculator? Using the trace, you can find the maximum, you can find the minimums. You can't do end behavior. You have to understand end behavior by looking at the graph and knowing that it keeps going wherever it ends on your display. But the X-Intercepts, you can get that from your calculator. The Y-Intercept, there's a real easy way to get the Y-Intercept. It's the number right there. Why? Because the Y-intercept means X is 0, correct? When you're on the Y-intercept, X by definition is 0. So every term that has X in it disappears. If I make X 0, those all go away, and the only thing I'm left with is the constant. So the Y-intercept is always the most easy thing to get, whether it's a quadratic, a cubic. What's the Y-intercept over here? +2. Same as that one, because all the X terms go to 0 when you let X equal 0. Okay? Now, the X-intercepts are a little harder. You're going to let that equal 0, but your calculator, again, is going to give you these zeros, which will be that point, that point, that point, and that point. Those are going to be your X-intercepts. Okay? Again, you can get all those numbers from your calculator, which I imagine is what they want you to do. So let's see. What we got? We got just a few minutes here. Let me just have a gander at some of the rest of these here. All right, let's have a look at 16 is basically the same as 14. It's a quartic. What's the Y-intercept on 16? No. Remember how you get the Y-intercept. You let X be 0. You let X be 0, what's Y equal to? The constant. It's always the constant. You see why? In other words, if I'm going to plug in 0 for X, all these terms disappear. And that's exactly how you get the Y-intercept, is you plug in 0 for X. So it's 0 to the 4th minus 0x, or minus 6 times 0, plus 3 times 0, plus 10 times 0. All those go to 0. So the only thing you have left is that constant. Okay? So getting the Y-intercept when you have a full polynomial is a piece of cake. It's always the constant. When you have this, a little bit harder, what's the Y-intercept there? How are you going to get it? How are you going to get it? There's no constant. So what do you do to come up with the Y-intercept? What's X equal to when you're talking Y-intercept? No. Here, I'm going to draw a graph like that. Here's the Y-intercept. What's X equal to right there? What is the X coordinate equal to on that point where I cross the Y-axis? Read it. Read it off the graph. What is that point? No. Nope. No. Which do you list first when you're listing the X and the Y coordinate? Okay. So back to my original question. What is the x value whenever you're on the y-axis? What is it here? What's the x-coordinate? Okay, there's your key. You're going to plug in 0 for x. Now, solve that for y. So you have y equals 1/6 times 3 times -2 squared, correct? When you plug in 0 for x, that's what you end up with. Now simplify that. Which one do you do first? It's not -6. Where are you getting -6 from? PEMDAS. Always do your exponents first. So what's -2 squared? Now what's that? What is that? Simplify that for me. Okay. There you go. That's the y-intercept. In other words, if it's in this format, all it is that. But this isn't in that format. This format here is in a factored format. So I can't tell immediately what the y-intercept is, but the concept is the same. Y-intercepts are where x equals 0. X-intercepts are where y equals 0. So if I wanted to know the x-intercepts, I make that 0. And then I just solve for that. Okay. So anyway, I will let you go for tonight. And work on your arithmetic, Brandon. That's your biggest weakness. And you know how to do that, right? You have that page? Okay. I would get on there and get good at it. It's not just knowing it. You got to be proficient at it. And you got to be quick at it. It doesn't do any good to be able to know what 7 times 8 is if it takes you 5 minutes to figure it out. The calculator will be faster. But once you get really good at these things, this arithmetic stuff, then it's way faster doing it in your head than it is doing it with a calculator. Way faster. And as you can see, that there are dozens of problems where you have to do a dozen steps. You got to do a dozen multiplications, additions, subtractions of positive and negative numbers. So you want to be good at it and you want to be quick at it. And the only way to get that is to practice. You haven't practiced enough that you're really good at it yet. And it's going to make all of this higher math more difficult until you get really good at that. Okay, so I would just spend like 5 or 10 minutes every day playing on it. Treat it like a video game. Okay? Brandon? Okay, I'll talk to you next time. Bye-bye. Bye-bye.